Welcome to EDU World Space.
In this question, we have two metal spheres, okay, and they are 2 meters apart. Okay, each of them has a radius of 3 cm. Okay, so here's 1 and 2. Q1 is um, Q1 is 10 nanocoulomb. Q2 is negative 30 nanocoulomb. Okay, so so we want to find the electric potential due to the two spheres at different points. Okay, so the first point is the midway between the two charges, and then the second point is on the surface of sphere 1, and lastly on the surface of sphere 2. Okay, so this is part A, and this is part B, and here this is part C. Okay, so to solve this problem, okay, we know that okay, the electric potential is the sum of the contributions of the individual spheres. Okay, so in part A, okay, at the midpoint, okay, so at the midpoint, okay, we have V equals to V1 plus V2. Okay, for each V it is Q1 divided by 4 pi epsilon naught D, and then Q2 divided by 4 pi epsilon naught D. Okay, in this case the distance are the same, so I'm just label it as D, and here D is 1 meter. Okay, and so if you calculate this, you have 8.99 times 10 to the 9 because they have the common term, and then Q1 plus Q2. Okay, Q1 is 10 nanocoulomb, and then minus 30 nanocoulomb. Okay, and then divide by 1. Okay, so you can calculate the V to be negative 1.8 times 10 to the 2 volts. Okay, so this is the answer for part A. Okay, then in part B, okay, we want to calculate the potential at the surface of sphere 1. Okay, so V1 is equal to 1 over 4 pi epsilon naught, okay, times Q1 divided by R plus Q2 divided by D minus R. Okay, here D is 2 meters. Okay, yeah, so maybe in part A I would put D over 2, D over 2, just to make it consistent. And so this is 2 meters. Okay, so you can put in the numbers, 8.99 times 10 to the 9. Okay, so the reason why there's a D minus R is that, so this is D, and then this is the R. Okay, so yeah, so here the effective distance becomes D minus R. Okay, Okay, so put in all the numbers. Okay, and you calculate this, you get 2.9 times 10 to the 3 volts. Okay. Okay, next in part C. Okay, part C is a similar approach as part B. Okay. So at the surface of sphere 2, okay, so V2 is equal to 1 over 4 pi epsilon naught times Q1 over E minus R plus Q2 divided by R. Okay, so we put in the numbers. Right, so calculate this, you get negative 8.9 times 10 to the 3 volts. Okay, so this is the answer for part C, and that's all for this question.